Okay, so I deleted that last part of the video because I got called out, and we're going to start right here. So we are at our second example. So I. So I have 25m squared minus 30mn plus 9n squared. All right, so no GCF. I'm going to use slide and divide. So I have m squared minus 30mn plus 225. And here's what I am going to do. We've done a problem like this before. I'm going to ignore the ends. I'm going to ignore the ends, and I'm going to write myself a note that just says add in to both my factors. Okay, I'm going to add the in at the end. So I'm looking for two numbers that I can multiply together to get 225, that when I add them, I get a negative 30. Well, that's negative 15 for both. So this factors out to m minus 15 times m minus 15. But I have to now do the divide portion. I have to divide both of these by 25. Divide by 25. And when I put this into my calculator, I actually get m minus 15 over 25 is the same thing as 3/5 times m minus 3/5. Well, remember, we don't factor with fractions, so I have to take the denominator and move it out in front. So this is really 5m minus 3n times 5m minus 3n, and it can actually be written as 5m minus 3n, the quantity squared. So 5m minus 3n, the quantity squared, is example B. So I and B match. All right, so now I'm going to do triple I, 25m squared minus 30mn minus 9. So 25m squared minus 30mn minus 9n squared. So I'm going to ignore the n's. So I'm looking for two numbers that multiply together to give me a negative 225, that when I add them, I get a negative 30. Well, again, it's going to be a negative 15 and a negative 15. However, a negative times a negative is a positive, and a positive times a positive is a positive. So this is not factorable. This is not factorable. So I matches example D. And by process of elimination, IV matches example A. And I'm going to show you. It becomes 5m plus 3n times 5m plus 3n, or 5m plus 3n, the quantity squared. Okay. All right. What is the factored form of this example? Well, notice when you look at your answers, the first thing that you see is everything was divided by a 6. So I'm going to drive 6 down to my denominator, right? Or down to the bottom, drive it downstairs. So I have x squared minus 10x plus 50. So what two numbers can I multiply together to get 50, that when I add them, I get a negative 10? Well, probably positive 10 and a negative, oh, that's not going to work. I'm looking for a positive 50 and a negative 10. How about when I divide by 6, this is 25, not 50. How about that? This is 25. So two numbers that I can multiply together to get 25, that when I add them, I get a negative 10. That would be a negative 5 and a negative 5. So this factors out to be x minus 5 times x minus 5, which is the same thing as 6 times x minus 5, the quantity squared. Example C. Number 8, how do the average rates of change for f of x and g of x over the interval compare? So first of all, average rate of change. This is the same thing as slope. That's all it's asking you about. It's asking you about the slope. So for the f of x function, I have negative 0.5 times x squared. I have to figure out what the output is when x is negative 5 and when x is negative 2. Well, when x is negative 5, I'm going to show my work right here. That gives me negative 0.5 times negative 5 squared. Well, negative 0.5 times negative 5 squared is negative 12.5. And when x is negative 2, I have negative 0.5 times negative 2, the quantity squared, and that gives me a negative 2. So my change in y plus 10.5 and my change in x plus 3. So the average rate of change of f of x over the interval of negative 5 to negative 2 is 10.5 over 3, which is the same thing as 3.5. Now let's look at our g of x function. Again, we're going to plug in we're going to do it the exact same way. So g of x is negative 1.5 times x squared, and I have to let x equal negative 5 and negative 2. So when x is negative 5, I have negative 1.5. Negative 5 times negative 5 is 25, and that actually equals negative 37.5. And when x is negative 2, that's negative 1.5 times negative 2 squared, which is 4. And negative 1.5 times 4 is negative 6. So this has a plus 31.5 over a plus 3. So the average rate of change of g of x is 31.5 divided by 3, which equals 10.5. So I said that the average rate of change of g of x is greater. Whoops. I need to plug in. I said that it's greater. And how many times greater? Well, it's 3 times greater. So is 3 times greater than the average rate of change of f of x. Okay, so I'm going to leave that there for a second. The last one that we have is area. It's an area function. Okay, so I have 2 pieces of material or 2 pieces of fabric, and we can represent their areas by these polynomials. So I called this number 1, piece number 1, and I called this piece number 2. So if I think about this, piece number 1, so the area of number 1, 12x squared plus 24x plus 12. Well, the first thing I did is I took a 12 out, and that gave me x squared plus 2x plus 1. So this factors out to 12 times x plus 1 times x plus 1, which is the same thing as 12 times x plus 1, the quantity squared. Number 2, the area for the second shape or the second piece of material can be represented by 3x squared plus 78x plus 507. So I took a 3 out of here, and that left me with x squared plus 26x plus 169. And this factors out to x plus 13 times x plus 13, which is the same thing as saying 3 times x plus 13, the quantity squared. Okay, so those are the factors for each expression. So if the table is 6 feet long, what are some reasonable dimensions? So that means that the length, one of the sides, so let's say that the length is the longest piece. So the length of the first piece. Let's say that the length of the first piece is 12 times x plus 1, and we're going to say that the width is just x plus 1. Well, what are some possible dimensions? We can't go over 6 feet. Well, the first thing that you need to know is this is given to me in inches, right? These dimensions are in inches squared. So I need to figure out how many inches are in 6 feet. So the amount of inches in 6 feet is equivalent to 72. So if the length is the longest piece, the 12 times x plus 1 cannot be any bigger than 72. That's the largest it can be. So let's see, 12 times x is 12x plus 12 equals 72. I'm going to subtract 12 from both sides. So 12x equals 60, which means when I divide both sides by 12, that x equals 5. The largest measurement possible for the first piece of material happens when x equals 5. So let's check the second piece. And I'm going to do the second piece kind of the same way. I'm going to say that the length is 3 times x plus 13. And that can't be any bigger than 72. So let's see. 3x plus 39 equals 72. I'm going to subtract 39 from both sides. So that gives me 33, I believe. 3x equals 72 minus 39 is, yes, 33. So 3x equals 33, which means x can't be any bigger than 11. But if I let x equal 11, piece number 1 is going to be very much bigger than it's allowed to be. Okay, piece number 1 is going to be much bigger than it's allowed to be. So the largest x value is 5. So what are the reasonable dimensions of x? Well, x could be 1 or 2 or 3 or 4 or 5 inches, or kind of any number in between there, right? So we're going to say that 1 is less than or equal to x is less than or equal to 5. Okay, so that's how we do that. And that's it. That is it. So these are your two